So hi folks, I'm Vasim Raza and today I'm representing Team Shiftux. The problem statement today we are dealing with is enhancement of permanently shadowed region of lunar craters captured by OHRC of Chandrayaan-2. Well, to deal with this problem, we have a solution. To this problem, the solution is specifically made for SIH Smart India Hackathon 2024. Well, let's get to the solution part. Well, the proposed solution is use of deep learning to enhance and upscale the PSR image captured through Chandrayaan-2. Well, what are we exactly doing? Well, we have divided, or I would say we have devised a multi-layer processing pipeline for which, well, of course, it will go through 4 layers of processing. Well, what are those layers? Well, for the first layer or the first phase, it would go through uh, data augmentation synthetically. Well, of course, why we are doing it, we will come on it later. So the first phase deals with data augmentation synthetically. For the second phase, we will deal with the lighting up of the low lit images. For the third stage, we will be upscaling those noisy images. And for the fourth stage, we are gonna detect or classify the lunar surface details. For the innovation and uniqueness part, if I say in one go, then testing out different models and different algorithms and fine tuning them to do a job specific, to target a job specific focus is what is we are innovating and what is our uniqueness. In the tech stack, you can see that it's Next.js, TypeScript, Python with Flask, Tailwind, GSAP, TensorFlow, Keras, OpenCV, PyTorch, and that's pretty common, I guess. But well, the data processing flow, I have already explained it. It's enhancing, denoising, upscaling, classification. Well, enhancing is not solely done by 0DC, but 0DC is the major one who's doing it. Same goes for the denoising, where IRD is doing it. Same goes for the upscaling. Well, in data augmentation, we are simply uh, augmenting new data through two processes, which is geometric transformation, where we are using Keras's image data generator. And next up, we are using noise injection via physics-based image formation model, where we are trying to replicate uh, the noisiness in a normal image. So how are we replicating the noise? Well, what are we exactly replicating? It's the shot noise, the thermal noise, the quantization noise. We are replicating each of those noises. Well, in the enhancement part, we are using 0DC and MIRNet. Well, both of them work a bit differently. 0DC is a self-supervised model, whereas MIRNet is a supervised model, but requires paired datasets because it's a supervised model. So the model with better accuracy will be used, of course. In the image upscaling part, the denoising happens through RIDNet. Well, real ESR GAN also does denoising, but in this case, uh, we are gonna do denoising through RIDNet and let real ESR GAN do the upscaling thing because uh, we need a better denoising in this situation. So that is where we are tweaking a bit. And well, for the object detection, we are using YOLO V3. And these models are not used in their parent form. We are tweaking in them for better results, of course.
We're talking about how it will look or how will we present it to you. Uh, let's give a look at the prototype of the of what we have prepared. So basically, mm, okay. So basically, this is the prototype we have built, like how we are going to present it. Since this project is more of a research based and a technical based project, so we have we have prepared a minimal prototype of how are we presenting it. So basically, this is the interface, that is Lumos's interface. Here we upload image, the image is uploaded, the hazy image as we can see. We enhance the image, and yep, the image is enhanced. We can even download it, like download HD. So like for now it's for ISRO, and if in future if we use it for business, then like for commercial purposes, then we can introduce pricing for HD and for limited use. So yeah.
And well, feasibility and viability. The technical part is of course feasible because there are resources. The operational feasibility is also possible because this problem statement is hosted by ISRO themselves. Well, time and cost feasibility. It will take time and it will take a bit of cost, but that will be of course worth it. Well, the only potential challenge that we face is resource feasibility because of very limited amount of lunar quality lunar data and very limited computational power. We can't go to the next level, but of course we are overcoming them. If we get a better computational power and better quality lunar data, then of course we will be able to classify and detect lunar surface features to assess land ability and determine its terrains and many more. We can use YOLO V5 also. So apparently to overcome those challenges, we are uh, overcoming the quality data set. We are just replicating the conditions of lunar PSR. That is what that is what's happening in the first phase, which is uh, augmenting data augmentation synthetically. And compute about the computational power, we are doing it on small scale. That is why we are using YOLO V3. So, well, impact and benefit. Well, of course, it has a large impact. Well, the research work has been done by us. And for the benefit, it will also demonstrate the advanced application of AI in space exploration, positioning ISRO as the leader in the cutting edge lunar research in technology. Well, many there are already pre-existing research work on this specific topic. We have took inspiration from many of them. There are lists of research paper here from which we have taken a lot of inspiration, and we have collected the best of all, and we have still fine-tuned it to be the best in its job. So basically, the job specific focus. And there are the research papers are listed here, and there are the models which we are going to use for each of the phases. Well, for data augmentation, this and enhancing upscaling and detection. So that's it. That was it for the about Lumos, the product we are gonna build, and the product we have been researching and working about. So thank you.